All right, so what I'm going to do is I'm going to pull some popsicle sticks and just ask what you guys think is important on here, and then I'll highlight it. All right. So let's start with here. Ralph, what's one thing on this between these 3 pages do you think is very, very important for the EOC? Say it one more time. Anything dealing with linear functions, yes. A good chunk of the test is flat out linear functions. So anything in this category, linear functions, very, very important. Specifically, if I had to pick y equals mx plus b, where m is the slope, b is the y-intercept, and then, of course, the slope formula or average rate of change is y2 minus y1, x2 minus x1 if you're given 2 points. And that, again, is average rate of change. All right. Let's go with Riley E. What's one thing that you think is important on here? Say that one more time. The formula for... Sorry, I just can't hear you really bad. The formula for what? Right. All the property of exponents. So, in case you ever have to deal with anything specifically in the polynomial department, anything with exponents, your exponent rules are fairly important. So, multiplication rule, power rule, negative rule, zero rule, and division rule. All of these are very important. Really, all of them are important, but those are like kind of the highlights. All right, let's go with Addie. What do you think? Anything regressions. All right. So if we're in regressions, again, you can use Desmos or your TI, it doesn't matter. Biggest thing that you want is this and this. That's what you would type into Desmos for linear and exponential. Now, one other thing you might want to add is quadratic, because you may get thrown a quadratic regression, and that'll be y1 squiggle ax1 squared plus bx1 plus c. So that might be something you might want to write in. All right, Ben, what do you think? What do you think is important here? The last page, which part? Oh, so like the exponential functions and the quadratic function part? Is that what you're talking about? Okay, yeah, that's important. So anything dealing with your exponential functions, here's the general form, growth formula, decay formula. Those are very important things you need to know, as well as quadratic standard form, as well as some of its different key features. Those are also very important to know. All right. All right. Now, here's some of my takes on what's important. besides what's already been said. So, my takes. You need to know the Pythagorean theorem. All right. You gotta know some basic formulas. So, area, perimeter of rectangles, area of triangles, area of circles, circumference of circles. You just need to know them because they may get thrown at you. You need to know the midpoint formula. Distance formula, not so much because you can use Pythagorean theorem. All right. When in doubt, graph it, use Pythagorean theorem. All right. You're also going to definitely want to know anything dealing with systems. So, whether you find the intersection, parallel for no solution, infinite solutions, and how the different ways you can solve by graphing, substitution, elimination. Now, anything statistics-wise that's also very important, specifically your one variable, but remember, most of that can be put in your calculator anyway. If you want to make a note of that, so in your TI, all you do is hit the stats key, you hit edit, input your table, then you hit stats, your right arrow key, then hit 1, then hit enter a couple times. And that'll give you all of your basic stats. So like your mean, your median, your 5-number summary, standard deviation, all that good stuff. So that's how you do it within your TI. You could do it in Desmos, but it's a little bit more complicated in Desmos. I feel like if you just need like the one variable stuff, just do it in your calculator because you have access to both. All right. And then the last thing that I definitely know that you're going to be asked 1,000 times on the EOC, or at least 2 or 3 times, anything dealing with perpendicular or parallel lines. Remember, perpendicular, they meet at 90-degree angles, and their slopes are opposite reciprocal, meaning if you have 3/2, the perpendicular slope is -2/3. Parallel lines, they never intersect, and they have the same slope. I can guarantee you'll be asked at least 3 to 5 questions on perpendicular parallel lines alone. Now, this doesn't cover everything, like, say, factoring, your polynomial operations, but this is a good stuff for, say, pretty much everything else. So what we're going to do real quick is we're actually going to add on, so on the very back side of this paper where it's blank, we're going to add on our own brain dump, which deals with factoring. All right, factoring and anything polynomial-wise. So on the very back of your paper, all right, and you can make this as pretty as you want, but we're just going to deal with anything polynomials. All right, so it doesn't have to look exactly like mine. I'm just going to give an example of how prettifying you can make it, but it's up to you. So first thing you may need to know is monomial equals one term. So that can be 8x squared. Binomial is 2 terms. So that can be 2x plus 1. Trinomial is 3 terms. So that could be 3x squared plus 4x plus 6. And a regular polynomial four plus terms. So an example could be x cubed plus 5x squared plus 6x plus 2. And I would make a note off to the side, no exponents in the denominator or terms in the denominator, no negative exponents, nothing of that nature. So you can't have that stuff. And no radicals. All right, so if we go into the operations of polynomials, the add dash subtract first. So if we had 2x squared plus 4x minus 6 plus 5x plus 2, distribute negative if subtracting. So you would do that first. And then combine like terms. Then if you multiply, you can use either the box method or FOIL, where FOIL stands for first, outer, inner, and last. Then for either of these, let's say you had x plus 3, x minus 2. If you're using box method, you would multiply columns by their rows. And then combine like terms. Then for FOIL, if I had this, I would multiply the first, the outers, inners, and then the last, and then combine like terms. You guys following so far? So again, I'm doing this quick because this is just a quick reference thing. It shouldn't be something that like you use a bunch of examples for. And then lastly, we have factoring. Which you guys typically factor ax squared plus bx plus c. Now, since we did a lot with algebra tiles when we were factoring, I would actually draw a quick sketch of algebra tiles because I feel like that was a good visual for you guys. So you had a x squared. Let's say you had three x's here, two x's here, and then all the ones. So if we looked at it, it'd be x squared plus 5x plus 6, which is our expanded form. Factored, it's all about side length. So this would be an x side length. This would be an x side length. This would be one side lengths. This would be one side lengths. So we end up with x plus 3 over here, x plus 2 down here. This would be x plus 3, x plus 2, and that's factored. And then lastly, just the basic steps, which is just factor out GCF if there is one. Do the big X, which if we draw it, you need to have A times C on top, B on the bottom, and you need two numbers that multiply to give you A times C, add to give you B. So they need to multiply together and then add together to give us these. Then we do our reverse box. Which you always put whatever ax squared is, top left, C in the bottom right, and then whatever your two numbers with an x value after that, and you're just filling in these blanks. And I would make a note saying to start here. Then the last thing I would add is difference of squares, which all you really need for that is a squared minus b squared is equal to a plus b times a minus b. So I know that's quick, but again, that was just kind of a brain dump of everything dealing with polynomial operations, and that's exactly how it should be. All right. So again, you can make this as pretty as you want, but at least for right now, get the basic information. You can prettify it all later if you want to. All right. Mhm. All right. Now, what we're going to do for the rest of class today is I want to go through some of the word problems, the inactive word problems, short answers from that practice EOC that we took last week. But before we do that, I'm going to give you guys a 5-minute break and you can use the restroom, all that stuff. Wake up a little bit if you need to. So hold on to that brain dump because, again, it's a really good reference for everything that we're going to be doing throughout the next couple weeks. All right. It's at least a very good, like, not so much a one pager, but just something that's short and sweet so you don't have to keep flipping through your notes. All right. So go ahead and take your 5-minute break. You guys should be back in here by 8:30 or before the timer goes off. By the way, if you guys missed any part of all that brain dump, I do have it options that you can answer the paper.
You want me to show you a video? There's lots of food. Oh, wait, I have a pen. Sorry.
All right, guys. So, upsy daisy. Let's get back to it. All right. So, let's look at some of these inactive questions. And I pulled these straight from that practice EOC that you guys did last week. And so, here's how we're going to go through this. I would keep that brain dump out because it would be a good reference for these. All right. So, we're not going to go through all of them today. I'm just going to pick and choose a couple that I think are pretty important or some things that you guys struggled on. All right. So let's just start right off the bat with number 4. Now, here's what we're going to do. A lot of the word problems on the EOC, all right, very, very similar to what we see here. It's all very, if you know how to solve some of the problems, you can solve any of them of that type. All right, so we're looking at specific problem types. So, some general things when it comes to answering short answer questions that you may want to make note of. All right, so just some general steps. The very first one is identify the question. So, specifically, what is it asking you to do? The second step is identify important information. So any important information can be helpful because then that will help you attack the problem. And again, the method of attack is going to be different depending on the type of problem. All right, but what's going to happen is that we're going to practice a lot with short answer problems. And by the end of these couple weeks, when it comes to short answer problems or anything having to do with short answer problems, you will not look at a short answer problem and be like, oh, I'm not doing that, and then move on. All right. You will look at it with confidence and at least try it. All right. So let's kind of put this into practice. So, first off, what is the question here? So, before you even read the full problem, just identify the question. What's the question? Now, think back to English class, guys. What typically denotes a question? A question mark. What statement has the question mark? What is the value of B? All right. Now that we know what the question is, it's highlighted. Read the problem. So a line y equals mx plus b passes through the point 1, 6 and is parallel to y equals 4x plus 6. All right. So let that stew for a second. Think about it. All right. Let's go with Brian. What do you think is an important piece of information in this problem that I need? Say it one more time. Right. So passes through the point 1, 6. All right. What else is important? Keep pulling people that aren't here. Nope, not here. I am Olivia. What's another piece of important information? Parallel to y equals 4x plus 6. And then the last thing I would say is that you want the line y equals mx plus b. So, some things that we know. What's one thing that we know about this problem? Addie. Passes through that point. All right. Specifically, we're dealing with what type of function, Ralph? Linear. So anything we do is going to be linear. And then what does parallel mean in terms of linear? Taylor. So what does parallel mean in terms of linear functions? It has still a slope. If two lines are parallel, then they have the blank slope. The same slope. So when we talk parallel, we mean same slope. All right, so this is how you should attack a problem, guys. You're basically going through it. You identify the question first. All right, so if we're identifying the value of b, all right, now, since we said it's parallel to this line in the blue, what's the only part of that line that I need? What does parallel mean? Same slope. It's parallel to y equals 4x plus c. So what's the only part of that line that I need for the new line? Which one, the 4x or the 6? The 4x. We want the slope. So we're going to start our problem with y equals 4x plus b. We don't know what b is yet. Now, if it's an important piece of information, that means it's going to go somewhere in here. So when we talk about a point 1, 6, how do we typically write a point? What does a point represent? XY. So if we're given a point XY, what do you think we're going to do with it? Not necessarily solve, but you're on the right track. What do you think I'm going to do with those XYs? Plug it in. So I'm going to take 1, plug it in for X, 6, plug it in for Y, and then solve for B. So I have 6 is equal to 4 times 1 plus B. And then we solve. So 4 times 1 is 4 plus B equals 6. Subtract the 4 to both sides. What's B equal to? Guys, what's 6 minus 4? 2. So B is equal to 2. So does that make things a little bit more simpler in terms of how you attack a problem like that? Yes, no, maybe, so? What do you think? So Basically, when you attack any word problem, this can work for either active or inactive. You just need to identify the question first, circle it, underline it, highlight it, whatever you need to do within the EOC system, possibly highlight it because that's really the only option you have. Make sure it's in your face. Then highlight anything that's important. More often than not, this is a short word problem, but more often than not, they're going to give you a bunch of fluff that does not matter. All right? You need to decipher what's important and what's not. All right? Any questions on number 4? All right, we're going to come back to number 5 later, but let's look at number 6. This is an example of a problem that has a lot more fluff than what it actually needs. All right? So, what's the very first thing that I got to do to identify my problem? Riley M. So, what's the very first thing I got to do before I even read it? I identify the question. What's my question here? Just look for the question mark. Where's the question mark? Right. So let's break that down a little bit. So let's say we only want how many units of product does the company need to sell? We don't really need that. We only need how many units of product in order for a net income equal to 0. Those are the only parts that we need. Now, we can read it. So a company models its net income in thousands of dollars with a function f of x is equal to 9x squared minus 54x minus 144, where x is the number of units of its products sold. And then it has the questions, how many units of product does the company need to sell in order to have a net product equal to 0. All right. So let's go. Caroline, what's one important piece of information in there? What's probably the one thing that I'm definitely going to need with this? Say it one more time. Right. The function itself. So the function's definitely important. What's something else? Ben. So what's something else from this problem, Ben, do I need? All right, let's go with James. Right, X is the number of units of its product sold. All right. And then I would also include models its net income in thousands of dollars. All right. So let's look at the question again and prepare some attack. So if it's asking us how many units of product, what do you think we're solving for, X or Y? X. Why do you think it's X? What does it say in the blue? Because X is the number of units of product sold, all right? So if we're trying to find how many units of product, that means we're solving for X. All right? Now, in order for the net income to equal 0, So if I want to equal 0, am I going to plug in? We know we're going to have to plug in something somewhere. Is that 0 going to go in for X or Y? So think about it. If we're solving for X, that means the only other option for us to plug 0 in for is where? Plug in for Y. So we're going to plug in 0 in for Y here. So I have 9x squared minus 54x minus 144 is equal to 0. So what type of function is this first off? What's the 9x squared minus 54x minus 144? What type of function is that? We definitely know it's not linear. So there's two other options, exponential or quadratic. Which one? So what do you guys think? Exponential, quadratic? You sure? It's quadratic. So remember, exponential means the x is in the exponent. That's why it's called exponential. X is in exponent. Quadratic means it has an x squared in it somewhere. All right. So this is a quadratic. So we're solving quadratics. What's the only way besides graphing that we've learned to solve a quadratic in this class? By what method? Starts with an F, guys. Solve by factoring. So we're going to solve quadratics specifically by factoring. Now, we just did a whole thing on this on your brain dump. So, what's my first step when we're doing anything with solving by factoring? Or just factoring in general? We have to do what? We have to find a what first? A GCF. Do you think there's a GCF? I would say it is. What do you think it is? 9. So we're going to first divide all of our terms by 9. Now, 9 divided by 9 is what? 1, so this is x squared, minus 54x divided by 9. What's 54 divided by 9? It's a multiplication table. 6x. Now, 144 is not a multiplication table, at least in terms of 9, so you may have to do a quick long division. So how many times is 9 going to 14? Once, so that's 9. Subtract it. It's 5. Bring it down. That's 4. How many times is 9 going to 54? 6 times. It's 54. Subtracted 0. So 16. So minus 16. Now, remember, when we solve by factoring, if we have a numerical GCF, it no longer matters because we'd end up dividing it out anyway. So you can cross it out. So after we find a GCF, what's the next step in factoring? Big. Guys, I know it's Monday, but you got to kind of wake up. All right. So big X. So we need A times C on top, B on the bottom. So what goes on top? Negative 16. 1 times negative 16 is negative 16. What goes on the bottom? Negative 6. So I need two numbers that multiply to negative 16, add to negative 6. So I'm going to list some factors of 16. What are my factors of 16? 1 and 16. What's another? Not 2 and 7. 2 and 8. And then 4 and 4. So if we have a negative number, a negative product, that means one of our factors has to be what? Negative. So if I made one of these sets of numbers negative, only one of the numbers, so we're subtracting to get to negative 6. Which set of numbers would give me that? 2 and 8. And which one would have to be the negative one? The 8. So I have negative 8, positive 2. And remember, it's replacing the b, so we're going to throw the x's in. Then I do reverse box. So remember, your ax squared goes in the top left. Your c goes in the bottom right. Then we have negative 8x and 2x. So what times what gives me x squared? X times x, good. So now it's really easy once we get that step over with, because what times x gives me negative 8? Negative 8. What times x gives me 2x? Positive 2. So my two factors, x plus 2, x minus 8 equals 0. What's my last step when I solve by factoring? I take both of them and make two what? So remember, we take both factors, make two mini equations, and then solve for x. So subtract 2, x is equal to negative 2. Add 8, x is equal to 8. Now, remember, on the EOC, they only accept one answer. All right? So look back in terms of the problem. It's asking for what? What's it asking for? How many units of product do they need to sell? So let's think logically. Can we have negative number of products? No. So what do you think my answer is? 8. So we throw out this one. We only care about x equals 8. So guys, if you're in the calculator inactive section and they throw a solving a quadratic at you, more often than not, it's going to be a solve by factoring. All right. So knowing how to factor and how to solve by factoring is very, 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 very important. Oh, wow. You guys are about to pass out. Okay. So all right. Let's do how do I go about this? Let's do one more. Let's do number 14. All right. So number 14, it's a whole question, but specifically within the question, what does it want us to find? The value of x. What is the value of x? All right. And it's a system of equations. Now, we know this is the inactive section. So look at your brain dump where it says systems. There's only 2 viable ways to solve a system without a calculator. Which 2 does it have to either be? So systems is on the second page of your brain dump. We're in the calculator inactive, so there's only 2 ways that we could solve this. Elimination or what? Substitution. So we can either solve by elimination or substitution. So remember, when we talk about elimination, that means we have both equations in the form ax plus by equals c. Substitution is when we have one that is either y equals or x equals. So one of our equations is either y equals or x equals. So which do you think we're going to use? So look at our system of equations. Based off of what I just told you, which one do you think we're going to use? Well, what method? Elimination or substitution? Substitution. Because we have this one that says y equals 1 minus x. Now, if we're using substitution, what does that imply? We're doing what? It's in the name. We're substituting. All right, so in other words, we're substituting one variable for an expression. Now, looking at what I just circled in green, so the y equals 1 minus x, we want a singular variable that we're going to replace with the expression. So if I separate the two, which side is the singular variable, which side is the expression? So the y is the singular variable, 1 minus x is the expression. So we replace the singular variable with the expression. So in our top equation, which variable am I replacing? So we replace variable with expression. So we substitute for which variable up top, the x or the y? What singular variable were we given? So guys, what's the singular variable with the equal sign of our second equation? What's by itself? The x or the y? The y. What's the expression? 1 minus x. So if we're replacing a variable with the expression, which variable am I replacing? The y. All right? You replace the singular variable with the expression it's equal to. So we're taking the y, replacing it with 1 minus x. So if I do that, I get 5x minus 4 times 1 minus x is equal to 1. And then we're just solving an equation. So what's my first step? So it's just solving a multi-step equation, guys. What's my first step? Distribute. So I get 5x minus 4 plus 4x equals 1. What's my next step? Combine like terms. So I get 9x minus 4 equals 1. Then what do I do? Add the 4 to both sides. 9x is equal to 5. Then what do I do? Divide by 5. Oh, whoops. I screwed up. Hold on. So this should be positive. This should be negative. So this should be. Sorry, guys. So you subtract the 4 to both sides. I transferred the problem wrong. So x is equal to negative 3. And we wanted the x value, so we're done. All right, so I can tell that you guys are pretty much checked out at this point. So what we're going to do is for the rest of class. Okay, let's actually do this first. All right, so put all that stuff away for right now. Here's what we're going to do next. So, in place of your exit tickets, I'm doing this thing called a math minute from now on. Now, here's how it works. It's all basic, nothing math one, it's all basic math. So like multiplication, addition, subtraction, elementary school stuff. There's 10 questions. Now, it's called a math minute because you can do this within 1 minute. All 10 questions in 1 minute. So, I'll be nice to you guys. I want time and give you 2 minutes. All right? It's literally super easy. So, you'll get a new one every week. All right? I will add up all 5 of them by the end of the week. How many points you get? All right? So, what I'm going to do is I'm going to pass these out face down. Write your name on the back side of the sheet. Do not flip it over until I tell you. All right? So I'm going to lay these down face down on your desk. Do not flip them over until I tell you to. But write your name on the back of the sheet. So write your name on the back of the sheet. Do not flip it over until I tell you to. What did I just say? So write your name on the back of the sheet. Do not flip it over until I tell you to. Now, if you finish early, flip it back over until I call time. Don't try to turn it in or anything. Just flip it over. All right. So I'm going to set a timer on my phone. 2 minutes. All right. Trust me, it's very doable to do it in 1 minute, but we're going to start with 2. All right. Is everyone's name on the back of the paper? All right. Your time starts now. So if you don't know it, move on to the next one. You're trying to get the most done possible. All right, time's up. Flip it back over. All right, go ahead and turn them into the box. Make sure your name is on it. That's one person.